Hi guys, we're going to start our last part of Unit 2, and we're going to start by making sense of slope. So we did slope and Y-intercept and rate of change, and now we're going to apply that to everyday situations. How are we ever going to use this? So what are applications of slope and Y-intercept? So let's take a look at this problem. The data table to the right represents the approximate wind chill temperature in degrees Fahrenheit for a wind speed of 20 miles per hour. So it's the wind chill temperature in degrees Fahrenheit for a wind chill speed of 20 miles per hour. We're going to use this data set to complete the tasks below. So in letter A, we're defining the input and the output variables for this set of data right here. So I'm going to do that up here where I have a little more room. Our input, which is this column right here. Another name for that is our x values. Another name for that is our domain. And it is also our independent variable. So what is that independent variable input x value domain measuring? It is measuring the temperature in degrees Fahrenheit. So we need to do the output, which is this column right here, which remember is our dependent variable. That's our output, or our y values. We also call that our range. And what is that measuring? It's measuring the wind chill in degrees Fahrenheit. So if you're wondering what wind chill is, when it's cold outside, when we have a certain temperature, say for example, the temperature is 0 degrees Fahrenheit. When the wind for this particular one is blowing at 20 miles per hour, that 0 degrees is actually going to feel like almost negative 22 degrees. So when the wind blows, it makes the outside temperature feel a lot colder. So we defined our input as the temperature in degrees Fahrenheit, and we defined our output as the wind chill in degrees Fahrenheit. So now we want to write an arithmetic rule for this sequence. So when we're looking at an arithmetic rule, we're looking for terms in a sequence. And I'm just going to use these two right here because this would be our first term in the sequence, this would be our second term in the sequence. So this is our a sub 1, this would be our second term, a sub 2. We don't have an a sub 0 or an a sub negative 5, and we're missing terms, we're missing 3 and 4 in between here. So if we're going to write an arithmetic rule for that, our first term is negative 20.668 degrees Fahrenheit. Our common difference, how do we get from one term to the next? Well, what we're going to do is add 1.312 over here. So our common difference is 1 and 312 thousandths. So when we want to write our arithmetic rule for any term in the sequence, our a sub n is our first term equals negative 20 and 668 thousandths plus our common difference, which is 1 and 312 thousandths, times the term we're looking for minus 1. So there's our general rule right there. Here's our first term, and our first term has to be where the input is 1. There's our common difference. How do we get from one term to the next? And it also works from this, from the 0 degrees to 1 degree, it's adding 1.312. And if we did it from here to here, and then divided by 3, we would still get 1.312. If we did it from the 5th term to the 15th term, we got this difference right here, and divided by 5, we would still get 1.312. So now we need to write an equation in the form of y equals mx plus b for this table right here. And again, because this is linear, it is arithmetic, we can use any 2 points to write the equation for our linear function. So if we want to write it in slope-intercept form, y equals our rate of change, just like we did up here, is 1 and 312 thousandths times x plus our y-intercept. And this is our y-intercept. This is when x equals 0, so it's plus negative 21 and 980 thousandths. So here is our arithmetic sequence, our general formula for this particular table, and here is our linear formula. And you can see my slope and my common difference are the same thing. So now we want to identify and explain the real world meaning for the rate of change and the y-intercept. So let's go back up and take a look at this the table right here. As the outside temperature increases by 1 degree, what's happening to the wind chill temperature? That's increasing by a little more than, or about 1.3 degrees. So as the outside temperature increases by 1 degree, the wind chill increases 1.312 degrees. And that's what we're going to write down here. So as the outside temperature increases, I'll put the rest of it down here, increases by 1 degree Fahrenheit, the wind chill temperature increases by 1.312 degrees Fahrenheit. The second part of that is what is the real world meaning of the y-intercept. The real world meaning of the y-intercept, so that's our rate of change. So our y-intercept, what that means is when the outside temp is 0 degrees Fahrenheit, the wind chill is temperature is negative 21.980 degrees Fahrenheit. Okay, now we're going to explain how to use the rate of change to find the actual temperature if the weather report indicates a wind chill of 9.5 degrees with 20-mile-an-hour winds. So this 9.5 degrees is the wind chill, so that's going to be our y, because that's the one that's in the output column, and we need to find x. So we're going to use our slope-intercept form up here, and we are going to plug in 9.5 for y, and we're going to solve for x. And so we get 9.5 equals 1.312x plus negative 21.98, and I knocked that last 0 off. Add 21.98 to each side, and what we end up getting is 31.48 equals 1.312x. Solve for x, and we get 23.994 degrees Fahrenheit. That's the actual temperature when the wind chill temperature is 9.5 degrees. Okay, now we need to graph the function. So I'm going to graph the function using the table, but our graph needs a scale. So I'm going to count by fives. So this is 5, 10, 15, 20, 25, 30. And I'm going to pause the video and fill in the scale, and then when you do the same, and then when I'm done, we will take a look, make sure our scales match. So I put in my scale, and now we're going to graph the points that are on the table. So the first point we're going to graph is -5 and -28.54. And that's going to be somewhere down here. Make my dot a little bigger. Somewhere down here, and we kind of have to estimate. Then we're going to graph our Y-intercept, which is 0, -21.980, which is somewhere around 22. I'm going to skip 1 and 2 only because I can't fit them in there, but we know this is linear, so now I'm going to go to 5, and that's a little bit more than -15, so right about there. Then 15 degrees Fahrenheit will give me a temperature of about -2.3, and then 35 degrees Fahrenheit will give me a temperature of about 24 degrees, which is right about there. And then if we connect these with a line, hopefully we get a linear function, and we do. So let's take a look at this whole thing all together. Our input was our outside temperature. Our wind chill was what the temperature feels like with a wind of 20 miles per hour. We wrote an arithmetic formula for that, an arithmetic rule, so we can find out the outside temperature or the wind chill with any temperature. Then we wrote it in slope-intercept form. We defined the real world meaning. So this is the temperature outside. This is the wind chill when the wind is blowing. And our slope was for every 1 degree Fahrenheit in the increase outside, the wind chill temperature increased by 1.312. And then we took that and graphed it to see if it was linear. And it is, so we did this right. So now it's your turn. Viper Video charges a membership fee per year in addition to the rental cost per tape, which I guess we really don't do that anymore, so let's say it's kind of like, sort of like Redbox. Using the table below, what is the slope in context? So one thing you want to keep in mind, this is going to be our X, or our input, this is going to be our Y in our output. So we want to know what is the slope in context. What is the change in the independent, or the change in the dependent, which is Y, over the change in the independent, which is X. And then the free response, using the table in number 1, what does the Y-intercept represent and what is its value? So remember, the Y-intercept is when X equals 0. Make sure you put these in the Google form. As I told you in class, I'm going to be randomly grading the multiple choice and the free response questions this quarter, but I'm not going to tell you which ones I'm grading. So please make sure you're putting your answers in there. Have a good night.